Okay, Assalamu alaikum to everyone. Welcome to my lecture series on calculus. So today it's our beginning lecture on the calculus. So today we are going to discuss about this topic, change of dependent variable with respect to independent variables. Okay, so it means we have defined a function. हमारे पास एक function defined होगा, चाहे वो फंक्शन कोई भी हो, लेकिन वो फंक्शन की जो डेफिनेशन है उसको सेटिस्फाई करेगा। ठीक है, तो उसमें क्या करेंगे हम कि अगर हम x की वैल्यूज़ यानी कि अगर हम इंडिपेंडेंट वेरिएबल की वैल्यूज़ में इंक्रीमेंट ऐड करेंगे, उसकी वैल्यूज़ हम चेंज करेंगे, तो हम देखेंगे कि y की वैल्यूज़ में, डिपेंडेंट वेरिएबल की वैल्यूज़ में क्या चेंजिंग आ रही है। डेफिनेटली जब आप इंडिपेंडेंट वेरिएबल की वैल्यू चेंज करेंगे तो डिपेंडेंट वेरिएबल की वैल्यू चेंज आएगी। आइदर वो चेंज हमारे पास कोई पॉजिटिव आए, नेगेटिव आए या तो ज़ीरो आए, लेकिन उसमें थोड़ी यानी कि इम्पेक्ट पड़ने वाला है एज वी चेंज द वैल्यू ऑफ इंडिपेंडेंट वेरिएबल्स। ओके, so I have written a definition of written the scenario कि how it will happens. So I have supposed a function generally y is equal to f of x, and if I wanna make a small increment inside a function inside independent variable x plus delta x, my delta x is any small increment I'm adding or subtracting from the original independent values, then my dependent variable will become delta y is equal to f of x plus minus delta x minus f of x. It means that if we are adding some increment inside independent variable, then the change occurred in a dependent variable will be equal to the value of the function at the final position of independent variable minus the value of the function at the beginning value of independent variables. So look at the example. Let's understand the definition of this one with the example. So I have considered an example of a quadratic function y is equal to x square, and I have supposed my initial value of independent variable is 1, and delta x, I have supposed the value of delta x is equal to 2. It means our initial value I can suppose my initial value ai xi is equal to 1, and my final value will be equal to xf is equal to, that will be equal to, so when I add 1 plus 2, then it will become 3. So my initial value is 1 here, it's 1 here, and my final value is 3 here, it's 3 here. Okay, and you can see at x is equal to 1, my value of f of the value of dependent variable is also a 1, and at x is equal to 3, my value of dependent variable will be 9. Okay, so that's a 9 here. And you can see this is my, I wanna change my color. This is what, this is actually, this is a delta x change in independent variable, and now I wanna find this value, this is change in y, delta y, and you can see delta y is equal to final minus initial. It means that delta y will implies 9 minus 1, and then of course delta y will be equal to 8. And graphically you have seen when you change the value of independent variable, definitely you can easily find the value of dependent variable. So algebraically how could you find? That will be equal to, it means that delta y will be equal to, and that will be equal to function at the extreme position f of x plus delta x f of 3, because 1 plus 2 is equal to 3, minus f of 1. So the value of the function at x is equal to 3 will be 9, and value of function at x is equal to 1 is equal to 8. So the value in the change of dependent variable when we change the inside independent variable is delta x is equal to 2 is 8. Look at another example. Find the change in dependent variable in sinusoidal function y is equal to 2 sine, and if x is equal to 0 and delta x is equal to pi. So here you can see my initial value is x. Okay, I can suppose my initial value xi is equal to 0 and my delta x is equal to pi. It means my final position will be equal to the final value of independent variable xf is equal to pi. Okay, so the change in dependent variable will be equal to the value of the function at the final value of independent variable, it means k pi, minus the value of a function at the initial value of independent variable is 0. Okay, so f of pi, you have to estimate the value of this sinusoidal function at x is equal to pi. Definitely I will obtain what? I will obtain 0, and value of function at x is equal to 0, definitely that will be also equal to 0. So you can see here the delta y is equal to 0. So when I wanna change the value of independent variable from 0 to pi, I wanna see the increment or change inside the dependent variable is 0. Okay, and graphically you can see here my 0 is here, initial value is here, and if I wanna find the change inside the dependent variable when I change 0 to pi by 2, this is my delta x1, this is my delta x1. Okay, and this is corresponding delta y1, and that will be equal to definitely will be equal to 2, and this is my, I have supposed this is my delta x2. Okay, so here the delta y2 will be equal to -2. So when I add them, I wanna find the total increment inside the dependent variable. When I add them, my answer will be 0. So finally I can say the delta y is equal to 0 when I add some increment from 0 to pi. Okay, thank you for watching this video.